Hello, my name is Gabriel, and welcome to a new episode from Concierge. Last time we left off on this page, performance testing page. We have ran our first tests, and we wanted to improve this page by splitting it into test runs and giving a friendly name to each test run. And then instead of loading all results, we want to see maybe a drop down of test runs available. Select one of them, and that one should load underneath. Clicking on one of those tests, there should be a model or a section expanding inside the table where we see a response. We don't care that much about the request itself because we mostly know it, but we do care a lot about the response. So let's get working. The prompt that we'll be starting with is improve the structure of the current file such that it also accepts a friendly name and a UID. The UID is the identifier of that batch of tests. The friendly name is a short name given by the user. Besides the load all results button, there should be a drop down showing all the friendly names of the batches previously run. And when we click on one of the batches, it should load all the tests from that batch and display them in the existing table. We have our plan. Something else that we would like to do is to update the currently existing tests from database into already having the UUID and the name of first run. The plan is finalized. Let's run it. While this is running, we should discuss a little bit about the test that ran yesterday. There was a behavior which we observed when we sent a batch of requests. Only 2 or 3 of them were actually calculated. The others were returned super fast with very high cache hit because the question was always the same. We are always asking about the same guest name. So in the next batch of tests, we should use different guest names. Even if we will be using the same ones every time, for consistency reasons, we need to have over 13 which we reuse. 5 we need for the sequential tests and 8 we need for the concurrent tests. For now, I will let it do for a while. We will not bother migrating the performance endpoint to SQL Alchemy and Pydantic because they are not the main functionality of the project, and whatever runs best or fastest for the LLM is good enough for us. If we consider that this should become a feature by itself, then yes, during one of the episodes, we will refactor this part. In the end, we had to run a migration and remove the dead code kind of manually in a new prompt. However, half of the work is done. In the SQLite Explorer, we have the 2 new columns. If we run a select at the end, we can see the generated batch ID and the first run. Let's validate that the website still works fine. Perfect. Now we want to go for the second prompt where when clicking on one of the table rows, we expand and show the response. And there we also want to add a new functionality, which is called response validated. For now, we will manually validate each response, and later on, we'll try to figure out how we can do it automatically. So the prompt will be as follows. In our run performance test, there should be a new boolean for each test called valid response. When clicking on one of the rows in the detailed results table, there should be a new component that toggles underneath that row where the user can read the response content. Inside this new component, there should be a switch with true and false. The value of that switch should be saved in the database under valid response. Good, I like this. Let's go with it. The first proposal has been done. Let's start the server and see how it looks. We select the batch. The reason why this has happened, it is because we did not run the migration. We just implemented the migration, but the new column doesn't exist. We can create it manually, or we can ask the LLM to do it. I'm wondering a little bit why it's not using a console script to do it, and it prefers to add it in the code all the time. Okay, this is okay. This is an interesting way of doing it. it tries to use the fast API hook to reinitialize or to add the missing columns on every project start. It is a creative approach, let's say. No, we will not go with it. I will ask it to reverse and run the migration manually. So I asked it to run the migration using the command line and remove the dead code. Indeed, it is a vibe coded project, but it has finished working. So let's try again. We have the table and the rows are clickable, but as we click on them, nothing really happens. Let's see if there is any error in the backend. It doesn't seem to be any error. Let's see if there is any error in the front end. Yes. Okay, this is an interesting method. I did not know about it. Good. So what we care about is how many times on for occurrences this is valid. Now let's look for one with, actually this one, 13. After it's finished working and a little bit of bug fixing, I have discovered a new need. I expand this and it says that it has a length of 1394. But I find it very difficult to understand what's the difference between this one that has 1581 and this one with 1394. So what I would like to do is to have maybe two checkboxes somewhere or any other way to compare two responses and to highlight the differences. I think maybe it is sufficient to have them side by side with one single vertical scroll bar in between. And let's see how it goes. This prompt, it's a little bit more vague than usual. We ask it to propose some options that would allow us to compare two of them side by side. I'm not very keen on the two-way display with one vertical scroll. Maybe there are other implementations that exist in the training set which are better UI-wise than this. Let's analyze the suggestions. Checkbox selection side by side model. Okay, this is what we had in mind also. Number 2. Click to pin first and click second to compare. I see this more fiddly than first. Dedicated compare view, full page. Add a compare mode toggle at the top. Probably this is more clean because this we can transform it in a component later on. Drag to compare. No, I prefer not to drag anything. Bonus, test diff highlighting. Yes, why not? However, since we don't have a front-end framework, I don't really see how JS diff will be solved. Let's go with the suggestion. I'm curious of the outcome, to be honest. It finished working. Let's start the server and see what happened. Okay, so we select the batch. We select big one and a small one, and then we can compare. Better than expected. I'll give it some feedback that scrolling feels a little bit strange and it's jumpy, but apart from that, it's actually what we needed. Probably the only extra request I would have to add the validation option, this one, in that field as well. Good job. So I'm going back to VS Code of the server. Now we are asking about the performance improvements for scrolling. Let's see if it can do anything about it, and then ask for the extra validation toggle to left and right, make our life easier. And I think that concludes our needs for the moment. Next step would be to select more guests that have the same number of occurrences. Ours had 4, so we need 12 more that have 4 occurrences, so we can send one of them in every other request. Okay, it finished something. Start the server, select the batch, select 2 rounds, we compare them. No, I don't see any difference, but for now it is usable. Further on, for sure, we will move to a front-end framework and things will get much better because front-end framework comes with event and management for things like this. Right now, everything has to be implemented by the LLM and it has a limit. So it's okay. Let's ask for the validation functionality. It finished working. We have restarted the application and refreshed the web page. So here's how it looks. Now we can compare one against each one of them. These are identical. So since everything is coded in JavaScript right now, we don't really have an implementation for reactive events. This will come by default when using a framework, but for now, this gets the job done. Comparison between concurrent and sequential would be slightly interesting because concurrent was cached between them, but sequential is recalculated every time. So it looks like first sequential and which one had these icons? Second concurrent, I think. So in the first sequential, check-in and checkout dates are one next to each other. And okay, at first glance, I would have considered that it missed checked out, but no. It is. It's just split by a pack. But yes, these are a lot more similar because they also have the same emote icons. Super. We did all of them and all of them were valid. Now we want to improve the customer name field to have a list of names instead of just one name. And each name should exist in the database 4 times. We went with the prompt where we asked to find a list of 13 customers with 4 occurrences. If he cannot find with 4, try it with 5 or 6. If there are not enough, mock some of them to have sufficient for this test. I expect it to run some queries first and then come up with a conclusion. And that should conclude today's episode. In the next episode, we will try different models and see different outcomes in order to select one that is fast enough for what we want to do. With 13 customers and 4 occurrences each, that's 52 requests. No, understand how it calculates. So we need 13 guests because first 5 will be used for sequential requests and 8 for parallel requests. So there was a little bit of misunderstanding. It wanted to initiate 52 requests, and now after a little bit of clarification, it will look into the database, I think, and find what we need. The plan has been created. We need 13 guests, correct. It will create a new generator script, good, and they will exist in exactly for reservations, good. We'll have a new endpoint, the setup one, and then in performance test, we will display a list and select it has done working, and we have started a server. Also, I already applied the refactor to use SQLite and Pydantic instead of raw queries when we interact with the hotel DB. We have the new batch ID. We have our test guests. Perfect. Now, before running the performance test, we should make sure that the init database is not called every time we run a new set of performance tests because we would lose the previous ones. And this alter table is not necessary. It can be included, or is it already? It is already. So this can be deleted. I'll let it finish so we don't overlap changes on the file. So refactor. On reading the code after some refactoring, we have confirmed that the behavior that exists right now does not take into consideration the new generated guests. So we want to have a new behavior where the first 5 sequential guests are used for the 5 sequential tests and the last 8 concurrent guests are used for the concurrent test. So in a web page, there should be 2 buttons, one for run tests with the same customer name and another one for run tests with different customer names. Correct? Yes. What we just described, it also imagined, so it can do the work. Cool. It is done working. The server is running. Let's refresh the page. We have our guests. We have to set up a new name. We want to run in a multi-guest configuration. The new name is different. We fetch model info. It has thinking enabled. Let's see. It has started. Now we can also bring in the LLM information. As we know from yesterday, the first request or the first sequential request will take a long time. So is this one? What we are curious about is the difference between second, third, and so on for sequential, and what happens when we send concurrent requests with different guest names. I think let's get the result because if I remember correctly, by looking at how the user prompt is structured, we send the customer name as the first thing and then comes the data from database. Therefore, I think this will invalidate all the cache all the time. I think the biggest performance gain that we can have is to move the data before the customer name, and that will reduce the prompt processing a lot. Let's see. On the previous run yesterday, the longest sequential request was 191 seconds, and then the others were in 159 range. So let's wait and see. By the amount of tokens generated, it is strange that it says that the first one was completed in 0 seconds. And as we can see here, it had to reprocess everything or almost everything. The KV cache usage at 60%, that's pretty low. There goes the third request. And as we can see, the cache usage starts from 0. So almost all of it is validated between requests. Here we can see what happened yesterday when we have sent the 8 concurrent requests. The first was calculated and the other 7 were waiting. And since they were using the same cache, they came out in the same time or almost in the same time. Today, it will not be the case. Another interesting observation is the prefix cache hit rate. This in VLLM is exactly the cache of the system prompt or the user prompt, and it has an eviction mechanism. As soon as it gets close to full, it starts to evict the older entries. And at the beginning of the test, we started with 90 something percent. This was during coding, because the way Klein worked was to keep as much as possible at the beginning intact, and then we went lower and lower by evicting values, and now we essentially hit 0%. So everything that has to be calculated for these concurrent batches will have to be brute forced. There is nothing left, and the KV cache is inside the request. This will have to be rebuilt all the time. Always goes from 0 all the way to 60%. This is insanely bad. Probably this is the best example why when we use LLMs to write code, the code that comes out is very, very bad. It is not bad because the LLM is mean against us, but because it's not taking into consideration the whole concept and all the layers. So I will let it run, but we can, and I will present the conclusion next time, but it's gonna be a while until it's done. So thank you very much for watching this episode. In the next episode, we will be playing with these prompts, system one and the user one, and we will try to get better results than what we have now. And we will also analyze a little bit the structure, since everything had to be recalculated every time. I expect the structure of the response to be slightly different. Yesterday, we have seen only 2 variations of emojis, for example. Now I expect to have more. So let's see. That's my assumption. We will validate this. So thank you very much for this episode, and see you in the next one, where we will really make some improvements.